Hello, my name is Sairaj Mirji. I am assistant professor in mechanical department of WIT Solapur. For this FDP activity, I have selected the course Automatic Control Engineering and my topic deals with basics of control engineering. Before dealing with the topic, I wanted to focus on control system. What is meant by control system? To control means to regulate, to direct, or to command. Hence, a control system is an arrangement of different physical elements connected in such a manner so as to regulate, direct, or command itself or some other system. For example, when a child plays with the kite, he tries to control it with the help of string, and entire system can be considered as a control system. In short, a control system is in the broadest sense an interconnection of the physical component to provide a desired function involving some kind of controlling action in it. There are some elements, that is plant, controller, input, output, disturbances. Control system may have more than one input or output from the information regarding the system. It is possible to well define all the inputs and output of the system. The input variable is generally referred as reference input and output is generally referred as controlled output. So moving ahead, there are two types of systems, that is open loop system and closed loop system. Open loop system and closed loop system. It is very generally easy to understand what is open loop system and what is closed loop system. If you see these two diagrams, in closed loop feedback system is there, that is feedback is provided. In closed loop system feedback is provided, and in open loop system it is not. So actual definition of open loop system is a system in which output is dependent on the input, but input, that is which is controlling action, is totally independent of the output or changes in the output of the system. It is called as an open loop system. It is very simple in construction, very convenient when output is difficult to measure, and are easy from maintenance point of view. These are not troubled with the problems of stability, but there are some disadvantages also, that is inaccuracy is there, unreliable, because accuracy of such systems are totally dependent on the accurate pre-calibration of the controller. So there are some disadvantages also. So to overcome all the these kind of disadvantages, generally in the practice closed loop systems are used. What is the definition of closed loop system? That is a system in which the controlling action or input is somehow dependent on the output, or changes in the output is called as a closed loop system. Where the feedback is provided. Feedback is a property of the system by which it permits the output to be compared with the reference input. So to generate the error signal based on which the appropriate controlling action can be decided. So here very simple two types of systems, they have diagrams are shown, which is not so complicated to understand, but if we see in detail, it should have a controller process to be controlled, feedback element, reference inputs, command input which call, and error detector, that is summing point. All these things has to be labeled, but to explain it in a simple way, I have just shown these simple diagrams. Moving ahead, this is a control system design cycle, which is very simple to understand. There are 6 steps. First step is determine a physical system and specification from the requirement. Second system, draw a functional block diagram. Third system is transform the physical system into a schematic. Step 4 is use the schematic to obtain a block diagram, signal flow diagram, or state space representation. And fifth step is, if multiple blocks, reduce the block diagram to a single block or closed loop system. Sixth step is very common, that is analyze, design, and test to see the requirements and specifications, whether they are met or not. So next we are going to see transfer function, which is a very important part as far as the control systems are concerned. So what is transfer function? Transfer function explains the mathematical functions of the parameter of a system. It's performing an applied input in order to produce the required output. Laplace transfer plays an important role in making mathematical analysis easy. So in any system, first the system parameters are designed and their values are selected as per the requirement. The input is selected to see the performance of the design system. So effect of system parameters can be defined as the ratio of output to the input. So mathematically, such function explaining the effect of system parameters on input to produce output is called transfer function. So actual definition of transfer function is that mathematically it is defined as the ratio of Laplace transform of output, that is response, of the system to Laplace transform input, that is excitation or driving function, under the assumption that all the initial conditions are 0. So somewhat here actually it is shown that how the system 1 and system 2 transfer function is shown for open loop and for closed loop. If the negative feedback is there, then the sign comes positive over here, and if positive feedback over there, then sign comes negative over here. That should be understood very well. So overall, this presentation carries some basic concepts of control engineering, and thank you for listening. Thanks a lot.